Hello everyone, this is Prasad from Subnero. In this video, we will be looking at setting up small networks. In the previous video, we looked at some of the basic concepts in underwater networks such as node addresses and protocol numbers. If you haven't watched the earlier videos, I would highly urge you to do so. By now, we understand that node addresses are used to identify different nodes in a network, whereas protocol numbers are used to send datagrams to specific applications on a single node. With our understanding of these concepts, let us learn how to set up and use small underwater networks in UnetStack. Let us start with simulating a simple 3-node network. By now, you should be knowing how to start a simple simulated network, and I will assume you can already run the simulation. We have 3-node networks in this network simulation here, namely Node A, Node B, and Node C. Let us first check the configured parameters on each of this network node by typing node on each of these nodes. So when I type node, it lists all the parameters of this node agent, and one of the parameters here is address size. So setting address size to 8 configures the node to use 8-bit addresses. All the nodes in this case are configured to use 8-bit addresses. The parameter origin is set to a specific GPS location in the lat-long format here. Obviously, the origin must be set to the same value on all the network nodes. Now, the location of the nodes are measured in meters relative to the origin, with x-axis pointing towards east and y-axis pointing towards north. Up till now, we have deployed 3 nodes in the network and we have verified the configuration of each of these nodes. First thing that you might want to check in the network might be the connectivity among the nodes. So in order to check the connectivity between the nodes, let's type in the following command on node A. So let's type ping node B, and that should just send a bunch of datagrams and it should look for responses. So ping command, this might be a familiar command to many of you if you have used IP networks. It works in a very similar fashion by sending a bunch of datagrams to destination node and looking for a response. It can be observed here that we transmitted 3 packets and we received 3 packets successfully. Same is the case when connectivity is checked with node C. You can try that by yourself. So UnetStack also provides a trace command, which can also be used to check the routes that exist between source and destination node. For example, on node A, you can type trace route to node B, and that should give you an output where it shows a list of node addresses and which tells you that the datagram originated at node A, it was reached node B, and it was sent back to node A. So up till now, we have seen connectivity. We have deployed 3 networks and we have also checked connectivity. Now, since we have connectivity between the nodes, we can make range measurements between the nodes as well. For example, I can type range to node B, and that should provide me the range measured from node A to node B. And similarly, I can also measure range to node C like so. So you can see that the range was about 530 meters to node C and range was about 370 meters to node B. So let's try and do something more useful with the deployed network next. We will do 2 things. One is we will transfer a text message from node A to node B, and second, we will transfer a file from node A to node B. To send a text message from node A to node B, you can type the following command on the shell of node A. It's quite simple. So you can say tell host B, that is tell node B, string, let's say hello, and on node B, you should say after a file hello appears. Similarly, transferring files is also easy in using UnetStack. So transferring files between nodes in a network is a common requirement since data is often stored in files. So file transfer and access to remote nodes are disabled by default. Let us enable this on node B where we are receiving the file. So I will type remote.enable is equal to true. Now that we have enabled remote access on node B, we can run commands on node B remotely from node A. For that, for convenience, let's store the address of node B in a variable B first. Followed by that, let's use the remote shell command, which is called rsh. So rshb just tells the following command to run on node B. So we would like to run a tell command saying hi. So this command just instructs the node B remotely to send a hi back to node A. And once we do that, you can see in a few seconds, hi should appear on node A, and indeed it does. Variable me is automatically defined to be the source node address once the remote access is enabled on node B. Next, to transfer a file, let us first create a file on node A. So let's create a file here. So in fact, if I look at the list of files, I already have a file here called abc.txt. So I could directly use the command fput in UnetStack, and fput puts a file from node A or wherever you are running this command to the destination node address, which is B in this case, and provide the file name, and that should do the job. On the shell from node B, we see the notification for the received file as a remote file notification. You might also want to transfer a file from node B to node A remotely, and for this purpose you can use fget command in UnetStack, but you need to make sure that the remote access is enabled on node A in that case. It is an extremely useful utility to be able to run commands on remote node. These commands are usually silently executed and the output is not sent back. But you might want to look at the output of the executed command or script. In that case, you might try something like this to check the remote node name. So if I want to check the node name remotely on node A from node A, then I would do something like rshb, and I would tell node B to tell me node.node name, and that should send me the node name of B, and it does. So since this is a common utility that is needed, UnetStack provides a simple way to run such commands by using a shortcut question mark. So instead of using tell me comma always, you can always use a question mark node.node name, and that should do the similar kind of job. So you understand the utility and you can explore more with different commands. Sometimes you're not interested in the output, but a mere acknowledgement on whether the command was successfully executed on the remote node. In such cases, you can always enable the ACK, and let's say I want to change the power level. So I could always change the power level to, let's say, -6, and after a while I should see a remote success notification, which is an indication that the instruction was successfully executed on the remote node. And after that, I can always switch off the acknowledgement. And that is it for this section on setting up and using small underwater networks. I would highly recommend you to go ahead and try the code snippets in the handbook by yourself. And if you have any comments or suggestions or questions, don't forget to leave them in the comment section below. Thank you and see you next time.